Thanks for having me. I'm Timo from Giant Swarm, and sadly I don't have Kelsey motivating my audience after lunch, but yeah! Thank you. So yeah, we're running Kubernetes in Kubernetes, and it's a little bit different from there have been talks around this where it's actually about having a self-hosted Kubernetes. This is a little bit different because we spawn new Kubernetes instances with Kubernetes, and I want to tell you a little bit about this and some background, some motivation why we're doing this. So we're managing Kubernetes clusters 24/7 and both on bare metal and not on Borg, and in the cloud. And we have our own data center, so it's this one. I live close to the Dutch border, and Kubernetes as a service is CAS, you know. And, so we have a data center in Frankfurt. We have some racks there. And we spawn Kubernetes clusters there for customers as a service, so they don't have to worry about their infrastructure. And but we also deploy Kubernetes instances in data centers of our customers, and that means, yeah, so an on-prem deployment for us could also be on AWS because it's the account of a company and it's inside their VPC infrastructure, and a little bit different from how we would run it on AWS. And so, but it happened to be that in those deployments we're also running more than one Kubernetes cluster, and there are a couple of reasons for that. Because, you know, soft multi-tenancy sometimes is not enough. There are companies that are big enterprises that have to gain some trust into the new technology to actually understand that they can run workloads on the same cluster that they have been separating very carefully in the past. So there are different reasons. So sometimes it's just that prod workloads shouldn't be interfered by testing workloads, so you want to have separate clusters for that. Sometimes there are teams that are working on different services that sometimes are like working with privacy data, sometimes with financial data, and those teams should be separated. And that's why we end up having multiple clusters in those on-prem deployments as well. And yeah, we believe that people must come to things in their own time, in their own way, for their own reason, or they never truly come at all. So in the end, we encourage everyone to use RBAC network policies because it doesn't make sense to have small clusters. Because if you have like dev, prod, test, and for each and every team, then you end up having a lot of machines but very small clusters on it. And in the end, that doesn't make sense. I mean, if you tear down one node of a 3-node cluster, 30% of your cluster is down, and that's no fun. And yeah, and obviously those technologies, we have 1.6 now. We already have RBAC enabled in 1.5, and it's now, you know, it's maturing, it's coming. People can adapt their processes, they will learn how it works, and so we hopefully don't run too many Kubernetes instances. But on the other hand, you can also easily spin up a new cluster and cluster with a new version to test your build chain, because your Jenkins is maybe integrated with the Kubernetes API, and you need to test this on some environment. So it's just one click to install a new version and test your build chain. So introducing Giantitis, and that's our main Kubernetes we use. And the motivation is rather obvious. We, providing Kubernetes for people, and we thought using Ansible for it doesn't make any sense for us. We want to use the same thing we're providing to others, and yeah. So definition. because it's on a couple of slides and a couple of diagrams, so G8S is the host cluster. It's the Giannitis. And K8 is the Kubernetes, the guest cluster we provide to the end users. And don't go to Kubernetes if you misunderstand the American pronunciation of the Greek people told me it's Kubernetes, actually. Anyway, so architecture. We have a control plane, and the control plane is actually the masters. So let's start down there. So us, the Giannitis admins, we're running the Giannitis masters. We're running a couple of infrastructure services, be it like networking, storage. We're running Vault for certificates. We're running Prometheus and Elk Stack and such things within the control plane. And then we have a couple of microservices that form our API. And then the Kubernetes masters are started within the infrastructure management. And on the other hand, we have an application zone where the actual nodes of the clusters are spawned, and we have the agents running, and where the application workloads can be scheduled to. And if you zoom out a little bit, and I'm not going into details, you have a bunch of services there that talk to each other, and in the end you have the clusters created on this side. So what do? So on bare metal, we don't have an API to spawn instances for the workers. So we decided to use a deployment with a pod, and the pod comes with a Docker image which has Chemo tooling in it and spawns a KVM. And within the KVM, we again have a core OS, and we configure the KVM via cloud config, and we're giving it some volumes. So, for instance, the certificates are generated outside of the cluster, but then handed into the cluster. The master, we can have just an ingress in the Giannitis to access the API of the guest cluster. So that's kind of easy. The Ingress controller in the guest clusters is either integrated into the load balancer directly, or we do some collation of ingresses. So we have ingresses read from the guest clusters and then added to the host cluster. So that also works. And we're running DNS, kubedns, and we're running the Calico policy controller to enable network policies. And to go a little bit into networking, because it's complex because of this inception thing. In the host cluster for ourselves, we're just using plain Calico. And within the guest clusters, we're using Flannel and Calico, but we're using it a different way than you usually use it in a Kubernetes setup. So we have one Flannel server per host. So in the recent versions, Flannel added a server client model. So we have one Flannel server running per host. And then we have clients per tenant on the machine. And we're using VXLAN as a backend. So to visualize that, it looks like this. 2 nodes, like physical machines. There's a Flannel server running. And then we add a tenant, so 2 VMs per node per tenant on a machine. And we have a Flannel client there. And actually, the VM is then connected through a bridge. And if we add another, inside we have the Calico then. So the users of the clusters can use network policies and such inside of their cluster. And then if we add another tenant, you can see we have another Flannel client running. So the Flannel client runs outside of the VM, and usually if you use Flannel within your Kubernetes installation, you would have Flannel inside of your Kubernetes installation. So it's just a way how we use VXLAN in between the VMs and isolate the clusters from each other. And yeah, we also have a certificate infrastructure, and we're using Vault for that. So we're creating a root CA per cluster, and then you have a PKI backend, so you can actually create a root CA and issue certificates and attach roles that allow you to issue certain certificates, certain CNAMEs, and in the upcoming or in the latest version, even organizations, which is important for the role-based access of Kubernetes. Each service within our guest clusters gets its own certificate issued by Vault and has a policy attached. And yeah, we went through some iterations with that platform. First, because we have been using Fleet a lot in the past, we just decided to launch different Kubernetes clusters on top of Fleet. But since nobody else is using Fleet anymore, we stopped doing that. And in the beginning, we started with just having YAML files and do some templating, and then start Kubernetes clusters. And then finally, we thought yeah, we want to use. We don't want to do the templating anymore, but we want to go for writing our own controllers. And we like the term operators because it's actually tasks we have been doing as operators manually before, and we want to just codify everything inside the cluster. So I want to go into a little bit of detail what we're doing there. So yes, it's codifying your operational tasks, and who of you has heard about third-party resources? Cool. So I don't have to explain it that much. Who's using third-party resources? Guys. Cool. So yeah, it's a way to easily extend the API, and we're doing this so we have a cluster TPR. So you can actually create a cluster object in Kubernetes, and then we have a KVM operator that watches the cluster TPR, and actually then goes and creates the deployment for the cluster. So the pods are spawned, and we actually have a guest cluster on it. We recently also started working on an AWS operator. So we can do the same thing, but instead of talking back to the giant Needis API to create the cluster in pods, we're actually talking to the EC2 API, the AWS API, to spin a cluster in AWS. And yeah, again, a little bit of visualization what happens here. So yeah, we have a cluster admin. He wants to create a new cluster. So he talks to the Giant Swarm API. Then we have a couple of our microservices involved. In the end, there's Kubernetes D, which is our layer that talks to the Giant Needis API. And this is just a regular Kubernetes API. So don't get confused. The G8 API is just a regular Kubernetes API that's our own Kubernetes. So it writes the third-party objects. So we have a cluster TPO and a CA and multiple certificates. And then, and we already create a namespace for the new cluster. And then in the next step, the operators start seeing that there's like a new TPO. And so for instance, the CA operator goes into Vault, mounts the PKI backend, creates a root certificate, creates the policies, and then as the certificate TPOs are created, a certificate operator can actually issue those certificates, and the KVM operator will create the deployment for the cluster. And yeah, same for AWS. So what does a cluster TPR define? It's like a lot of configuration options, everything that you can actually configure Kubernetes with, or all the components that are involved. For instance, like configuration options for Calico. We want to have the Ingress deployed already inside of the cluster. Yeah, we have some node configurations. So how much cores should the VM have? How much memory should the VM have? And stuff like that. And yeah, same for the certificate. So we have like a TTL, we have a common name, we have maybe the organization, we have to which cluster and component this certificate belongs. Yeah. And a short demo how this looks. So I need to switch the screen. I don't see my mouse. No, that's wrong, but there it is. So yeah, I need to look there. So if you go to our web interface, you have this shiny green button to create a new cluster. So I can do a kubecon cluster. And then I have the configuration. I can add some workers, or I can actually remove some workers, or I can, change some configuration, and then I can launch my cluster. And now I have a cluster, and I can actually go and create a key pair. So because I want to have access as a cluster user, so I create my own key pair. And I get some configuration I can put into my kubeconfig while the cluster is booting up. So let's see. So first of all, we can just use our command line to see what's the identifier of the cluster. Wi-Fi is really fast. So the identifier is that one. Actually, I can look here now. It's easier. So I can do a kubectl get cluster, and I see if I'm lucky, I see the cluster TPR created, and maybe this just takes very long. Don't know why, but I can also, get some pods and use the namespace. Or not. So usually you would see now what you've seen on the diagrams, that there are pods started with the workers, with the master, with the flannel clients. And yeah, you should also have like a definition of the cluster created within the Chinese API. So, Jono, should I steal this network cable? No, it doesn't work. Yeah, I also have a local cluster where I happen to have the AWS operator running. And I can do the same thing here, just without our API, just plainly on a Kubernetes. So here we have a cluster definition. It's very small. Make it bigger. So now we have a cluster definition for an AWS cluster, and we have actually one master, one worker here. And if I do a kubectl create example cluster, cool. If I'm lucky, I get some instances on EC2. Error. Yeah, I was very lucky with the demo gods today.
You need to change the context.
Oh yes, that's a good. Yeah, one person is awake. Thank you. So yeah, we should see some instances coming up here. Yeah, at least a master. Yeah, and if I delete this cluster again, then the operator takes care of just deleting the instances from the AWS API again. So yeah, that's basically it. And going back to the presentation. So yeah, what's coming next? So we figured out that having one big giant configuration in the cluster TPR doesn't make sense for us. So we want to have if there are things that have different life cycles, different lifetimes, and why not manage them with different operators? Why not go for microservices in terms of operators? So having one responsibility per operator, that makes a lot of sense. So we're breaking that down. We have already separated out the certificate management into its own operator. Before, we have been using that in init containers within the pods. So now we're doing that, and then the next thing is how do we manage the clusters? And that's maybe independent from, is it on AWS or is it on bare metal? So how do you roll your upgrade? Why not change just a resource in the cluster and say, I want to have a new Calico version rolled out in this cluster. And then our operator is there and just takes care of rolling that out. And for that, we're actually planning to put all the boilerplate we have in every single operator into a library, so we can make it simpler to have to create those libraries. We did the same thing for our microservices, and they were based on GoKit, so we called it MicroKit, and we also started using operator kit as a thing, but it doesn't really exist yet. So if you have feedback there, if you also create operators, please speak to us. We want to just encourage people and help people to build more operators. Yeah, and one very important thing is obviously we also want to have self-hosted clusters, but because if you then have all the components also running in Kubernetes, it's also easier to upgrade Kubernetes itself. Thanks. Questions? Do you have a microphone, somebody? Here's a microphone. I don't know if it works. Yeah.
Do you have one giant NetEase for everything or one per customer?
One per customer.
Okay.
Yeah, the deployments are really autark.
Okay. And how do you deploy the giant NetEase cluster itself?
That's the best question you can ask. So we're still working on that. I mean, we still have this chicken and egg problem that we also want to get rid of, especially if we do more and more deployments. So yeah, we have Pixie boot, and so mostly it's done by having a Pixie boot that configures the cloud configs to spin up the machines. But that's also the reason why we go more into self-hosted. So we want to make this main cluster self-hosted, so it's easier to upgrade and easier to install for us. So goal at the moment is to separate provisioning machines and actually bootstrapping the cluster itself. And then probably we're going to use kubeadmin or having some kind of operator that bootstraps, but mostly leveraging things that are already available through kubeadmin.
Thank you.
Somebody else? Thank you.